Hi, welcome to the 16th International Conference on Applied Human Factors and Ergonomics and the affiliated conferences at JW Orlando, Florida. This tutorial, Designing Ergonomically Smart Workplaces with AI and User-Centered Design, explores how AI and UCD can create adaptive, human-centered environment that enhance comfort, performance, and well-being. Blending ergonomics principle with cutting-edge tools, we will examine real-world case studies and offer practical insights to help you design responsive, intelligent, and inclusive workspaces. Let's reimagine the future of work where innovation meets user needs. My name is Dr. Javed Anjum Sheikh and I am from Fazaya College of Education for Women and Air University, Pakistan. My backgrounds at a glance, very simple, and my qualification PhD from Middlesex University Human Computer Interaction. Objectives and outcomes. Understand ergonomics and UCD. You will gain a foundation in ergonomics principles and how user-centered design ensures workspaces are tailored to the people who use them. Both disciplines emphasize comfort, safety, and performance by focusing on users' physical and cognitive needs. Explore AI's role in ergonomics. This session introduces AI tools that improve ergonomics outcome through automation, personalization, and predictive insights. These technology analyze postures, motions, and environmental data to suggest real-time improvement and reduce health risk. Apply framework for smart design. Attendees will learn how to use practical frameworks that combine design thinking, AI capabilities, and UCD design methodology. Uh, these tools will be applied across real-world scenarios, providing actionable guidance for both industrial and office environments. This session's learning goals are divided into three parts. Understanding the participant, apply AI, and using practical framework. These outcomes are designed to balance knowledge and implementation. Why ergonomics workplace matter: health, performance, and business values. Employee health and safety. Poor ergonomics can lead to repetitive stress injuries, chronic pain, and fatigue. Ergonomic design reduces their risk by aligning tools, workstations, and workflow with the body's natural movement and capabilities, ultimately improving physical health and preventing long-term disability. Operational efficiency and focus. Ergonomically optimized environments reduce unnecessary motion and discomfort, allowing employees to maintain focus and work more efficiently. When discomfort is minimized, individuals can sustain concentration and complete tasks with fewer errors. Cost reduction and compliance. Companies that invest in ergonomic design often see decreased insurance claims, improved safety compliance, and lower employee turnovers. Ergonomic is not only a health strategy but also a cost-effective business practice that reduces risk and increases overall productivity. This uh, tutorial connects ergonomics design to three outcomes: healthier worker, more efficient operation, and financial saving. The arguments frame ergonomics as essential for businesses sustainability. from traditional to smart ergonomics, the shift to intelligent adaptive system, from static to adaptive workspaces. Traditional ergonomic solutions were fixed and universal, offering limited personalization. Smart ergonomics introduces adjustable systems that adapt to each other's body size, postures, and work habits. These responsive environments provide a better fit and long-term comfort. From manual to sensor-based assessment. Previously, ergonomics assessments were done manually through observation and checklist. Today, sensors and wearables gather postures, motion, and behavior data in real time. This provides accurate and ongoing insight that help identify issues before they escalate. From reactive to predictive strategy. Classic ergonomics intervention often happen after discomfort or injury occurred. With AI and real-time data, systems can now anticipate risks by tracking early signs of strain. These predictive capabilities allow for proactive adjustment, reducing long-term health problems. This tutorial shows how technology has advanced the scope of ergonomics instead of reacting to problems. Smart systems predict and prevent them while adapting to each user's need. Role of AI in workplace innovation. Enhancing ergonomics through intelligent system. AI-powered risk identification. AI technology analyze movement pattern, posture data, and user behavior to detect ergonomic risk. By continuously monitoring activity, these systems identify repetitive strain indicators and alert user to safety teams before injuries occur. Real-time feedback and adjustment. Intelligent environments provide instant feedback through visual cues. For example, posture correction apps notify user when they slouch, or sit-stand desk remind them to change position. These adjustments help maintain optimal ergonomics throughout the day. Customized work environments. AI enables personalized workspace setting by learning user profile, including height, movement range, and preferred configurations. This level of customization enhances user comfort, increases engagement, and supports long-term health and performance. AI enables a shift from general ergonomics recommendation to personalized real-time support. Intelligent environments become active participants in user wellness and productivity. So, what is ergonomics? Understand the foundation of workplace comfort, definition, and purpose. Ergonomics is the scientific discipline focused on designing environments tool and the system that align with the capabilities and limitation of the human body and mind. Its primary goal is to reduce physical and mental strain, enhancing comfort, safety, and overall productivity in the workplace by adapting work condition to these user rather than the other way around. Ergonomics prompts long-term health and efficiency. Scope across disciplines. Ergonomics encompasses physical, cognitive, and organizational domain, making it a truly interdisciplinary practice. It applies to everything from hand tool to machinery to workflow and team communication structure. Whether it is minimizing muscle fatigue or simplifying user interfaces, ergonomics work across various fields to create holistic improvement in the work experience. Ergonomics in daily work, from desk height and screen positioning to assemble line design, ergonomics is embedded in everyday work environments. When applied correctly, it reduces discomfort and prevents injuries like MCD and our back strain. As organizations grow more aware of its benefit, ergonomics has become a standard for workplace quality and users' well-being. Ergonomics is the foundation for designing healthier workplace. It integrates physical, cognitive, and organizational principles to improve comfort, performance, and long-term safety for all types of workers. Principles of ergonomic design, core guidelines for healthy, effective workspaces. Fit the task to the user. Ergonomic designs begin with the concept of matching tools and environments to user rather than expecting user to adopt. Whether it is adjusting equipment for a user's height or simplifying a task to minimize efforts. The objective is to ensure physical alignment and reduce unnecessary strain. This principle helps improve both comfort and efficiencies in routine tasks. Encourage natural postures. Natural postures refer to the natural alignments of joints and limbs where muscles are at their least strained. Workspaces that support natural postures help prevent long-term MCD. Chairs with lumbar support, keyboard positioning, and monitor heights all contribute to maintaining this ideal alignment throughout the workday. Minimize repetition and static load. Repetitive motions and holding static positions for long periods are common series of fatigue and injury. Ergonomics design mitigates this by introducing a variety into two tasks, promoting movements and using automation where appropriate. These strategies help maintaining physical well-being and reduce chronic strain. Ergonomic principles focus on preventing injury and enhancing performance by designing systems that align with the natural body movement and cognitive capacity. They serve as the blueprint for human-centered design in any work setting. Cognitive, physical, and organizational ergonomics. The three dimensions of ergonomic designs. The first one is cognitive ergonomics. This domain focuses on how people perceive, remember, and respond to information. It deals with decision making, mental workload, and human computer interaction. Designing clear interfaces, reducing distractions, and supporting innovative navigation are core elements that reduce errors and cognitive fatigue. Physical ergonomics. Physical ergonomics addresses postures, movement, and force-related risk in the workplace. It involves designing tools, furniture, and tasks to match the user's body mechanism. Key concerns include sitting postures, reach zones, repetitive motions, and manual handling to prevent injury and discomfort. Organizational ergonomics. This area consider how system structures and workflow influence human well-being and performance. Factors like team dynamics, scheduling, communication flow, and job roles are evaluated. Poor organization can lead to psychological stress, inefficiency, and decreased worker satisfaction. These Three types of ergonomics from a complete model for workplace design. They collectively shape how people physically work, mentally process, and socially interact with an organization. Types of ergonomics risk. Identifying the source of strain and injury. Physical ergonomics risk. These risks arise from poor postures, forceful exertion, vibration, and repetitive movements. If left unaddressed, they can lead to serious MCD such as tendonitis, back pain, or carpal tunnel syndrome. Identifying and mitigating these risks through design improvement is critical for workplace safety and productivity. Cognitive ergonomic risk. Cognitive loads refer to the mental effort required to perform tasks. When systems are complex, unclear, or require multitasking, users become mentally fatigued or make errors. Poor interfaces design and unclear procedures increase stress and reduce concentration, creating an environment that undermines productivity and morale. Organizational ergonomics risk. These include factors such as poor scheduling, inadequate job rotations, or lack of role clarity. They might not cause immediate physical harm but lead to chronic stress uh, with burnout and reduced employment engagement. Organizational risk requires system thinking and policy level adjustment to improve the work culture and environment. Ergonomics risks go beyond physical strain. Mental load and organizational dynamics also affects performance and health. A comprehensive ergonomics strategy addresses all three to build a resilient workplace. Introduction to user-centered design, designing workplace around people. Definition of UCD. User-centered design is a framework that puts end user at the core of the design process, rather than assuming how people will behave. User-centered design investigates their actual needs, behavior, and challenges. This results in product and environment that are more innovative, accessible, and effective in supporting real-world tasks. Empathy and interaction. UCD is an interactive process that begins with empathy. Designers observe, listen to, and interview users to deeply understand their goals and frustration. Solutions are tested and refined through feedback, creating systems that are consistently evolving to meet user needs more effectively. Design for real context. Unlike traditional approaches that prioritize aesthetics or often efficiency alone, UCD emphasizes functionality in real-world scenarios. It ensures tools and environments perform under actual work conditions. This method leads to practical design that are easier to use, are less prone to failure or user error. User-centered design ensures that our people using a system are involved in its creation. It helps identify unmet needs, improve usability, and reduce friction by grounding decisions in real-world behavior and feedback. Integrating ergonomics and UCD, a holistic human-centered design framework. Physical and cognitive integration. Merging ergonomics with UCD creates a comprehensive approach to human-centered design, while ergonomics ensure the physical fit of workspace. UCD makes sure systems are innovative and meet user expectations. Together, they create environments that reduce strain, support cognition, and encourage safe, productive behavior. User involvements in ergonomics planning. Involving user directly in ergonomics decision-making results is more effective and personalized solution. Workers understand their own pain points better than anyone else, and their insight ensure that changes are practical. This inclusion also leads to higher acceptance and engagement with ergonomic intervention. Designing for diversity. Every workforce includes individuals with different abilities, preferences, and challenges. Combining UCD with ergonomics allows for flexible design that accommodate a range of users. Adjustable furniture, customizable interfaces, and inclusive policies ensure equity and usability for all. Integrating ergonomics and UCD result in workplaces that are physical, sportive, and cognitively innovative. This dual focus leads to better outcome and user and stronger performance for organization. Integrating ergonomics, UCD, and AI to create intelligent workspaces that prioritize both performance and human well-being. Why integration matters. The integrations help address both physical and cognitive user needs while allowing environment to adopt in real time. Ergonomics ensures physical comfort. UCD aligns design with user behavior, and AI adds intelligence by learning from data and adjusting system accordingly. Creating adaptive and inclusive workspace. AI can detect postural strain, stress level, or task inefficiencies and prompt automatic adjustment, like changing desk height or lighting. This creates a responsive workspaces that evolve based on user intention and feedback. A system level perspective. When ergonomics, UCD and AIs are viewed as interconnected systems, we can design smarter workflow, better interaction, and healthier environments. This approach ensures long-term usability, safety, and performance across various industries. Understanding human factors in the workplace, the interaction between people, systems, and environments for safety, comfort, and performance. Definitions of human factors. Human factors refer to study of how people behave physical, physically and psychologically in a work environment. It considers aspects like cognitive load, fatigue, and physical capabilities. The goal is to reduce error and enhance comfort, safety, and efficiency in task performance. Importance in workplace design. When designers take human factors into account, they tailor environments to fit the worker, not force the worker to adapt. This leads to fewer accidents, less fatigue, and improves user job satisfaction. It is essential for creating both physical and mental supportive workplaces. Ergonomics as a human factor disciplines. Ergonomics is essential that practical arm of human factor. It applies those principles to ensure that tools, tasks, and environments are designed with people's limitation and ability in mind. Whether that is reducing strain through better posture or simplifying tasks to match cognitive workflows. Common workplace design pitfalls. Avoiding errors that compromise comfort and safety. One size fits all solutions. Designing with an average user in mind often exclude a large portion of workforce. People vary in height, strength, and preferences, so static setups can lead to discomfort and injury. Adjustable tools and flexible spaces are necessary to support a wide range of users effectively. Neglecting cognitive load. Interfaces that are cluttered or systems that require frequent multitasking increase mental fatigue. Ignoring the cognitive demands of a task that reduce productivity and raise over rates. Throughout layout, cleaning, labeling, and simplified workflow can reduce this invisible strain. Poor lighting and environmental factors. Inadequate lighting, noise pollution, and poor air quality are often overlooked in design. These factors significantly affect concentration, eye strain, and mood. Attention to environmental ergonomics improve both physical comfort and mental focus on their workplace. Ignoring basic ergonomics principle leads to widespread inefficiency and user dissatisfaction. Avoiding this common pitfall improves safety, morale, and productivity across the board. User pain points and needs analysis. Discovering what user actually need. Identifying pain points. Pain points are specific problems users face in their duty work routines, such as reaching too far for tools or squinting at screen. Observing tasks, interviewing users, and reviewing injury logs help identify where the work environment is falling short. This data informs meaningful ergonomics improvement. Analyzing user behavior and preferences. How users interact with their workspaces reveal hidden inefficiencies, or discomforts. Some may favor standing desks, while others need more screen tilt or rest support. Tracking these patterns over time allows for solutions that better match real usage habits. Turning needs into design goal. Once problem and preferences are identified, they must be translated into actionable design criteria. For instance, if several users report back pain, the solution may involve adjustable chair or monitor stands. Aligning the design goals with real needs ensure targeted, effective results. Understanding user pain points is the foundation of effective design. Needs analysis bridges the gap between observation and action, creating systems that truly support user well-being. How AI support ergonomic design. Intelligent tools for safer workplaces. Data-driven ergonomics assessment. AI system can analyze postures, movement, and equipment usage through sensors and cameras. These tools detect ergonomics risks such as poor rest angles or prolonged static positions. The result is faster, more accurate evaluation than traditional manual methods. Personalized recommendation. Machine learning algorithms adapt to individual behaviors and recommend improvement tailored to the user. For example, a system might suggest height adjustment based on a worker's unique posture trends. Personalization increases comfort and long-term adherence to ergonomics practice. Continuous monitoring and feedback. Unlike one-time assessment, AI tools offer ongoing evaluation and real-time feedback. Alert or suggestions are delivered when unsafe postures or fatigues are detected. This continuous feedback loop helps reinforce good habits and prevent injury before it occurs. AI enables smarter, proactive ergonomics. It detects risk, learns from individual behavior, and helps maintain optimal working conditions through intelligent, personalized support. Sensor, computer vision, and posture monitoring. Technologies that see and understand movement, motion, and pressure sensors. These sensors track body movements, seat pressure, repetitive actions in real time. They are often embedded in chairs, desks, or wearable devices to capture postural shifts or prolonged static positions. The collective data helps flag risk-prone behavior or corrective action. Computer vision system. Using camera and advanced image processing, these systems analyze postures, joint angles, and orientation. This can detect slouching, awkward rest position, or unsafe lifting techniques. Unlike traditional tools, computer visions offer scalable, touchless analysis across teams. Integrated feedback interfaces. The data from sensors and cameras feeds into user dashboards or trigger instant feedback alert. These interfaces visualize ergonomic status and suggest adjustment. When paired with AI, they enable self-correction and learning through consistent, non-intrusive prompt. Sensors and computer vision make ergonomics measurable and dynamic. They provide a foundation for AI to monitor, access, and improve postures and motion throughout the workday. AI-driven risk assessment model, predicting ergonomics hazards before they happen, analyzing movement pattern. AI models can evaluate large volumes of postures and motion data collected over time. These systems identify recurring high-risk behavior like overreaching or twisting, which might not be noticeable during casual observation. Through pattern recognition, AI predicts where injuries are likely to occur. Predictive modeling. Machine learning algorithms create risk profile for specific role or individual based on historical data. They flag users show early sign of strain or fatigue, allowing reservation intervention before injuries develop. This makes workplace safety more proactive and cost effective. Real-time alerts and reports. AI systems generate dynamic feedback and summarize tailored to user and safety managers. Risk scores, posture heat map, and alert logs provide actionable insights. These reports support faster decision making and targeted ergonomic improvement across department. AI-driven models don't just detect issues, they forecast them. With continuous input, they refine their understanding of risk and help organizations move from reactive correction to proactive prevention. Please refer to the references and the end of this presentation for further detail and score material which you will use in forthcoming uh, exercises. Rolla Rapid Upper Limb Assessments. These are few pictures which shows correct posture and incorrect postures. It will help you to understand how we uh, design our workspace for better use. This is a sitting very low level, and the next one is a best posture. Again, shorter people often set the chairs right, and but if they have a foot rest, then it's the better for them. And that is a standing position, better than the sitting position, but both positions are better because they have a foot rest. Introduction to Rolla and its purpose. Rolla likes tool empower proactive ergonomics intervention for healthier workplaces. Rolla is a survey method for assessing posture-related ergonomics risk. Rolla Rapid Upper Limb Assessment is specifically designed to assess the risk of work-related MSDs caused by poor postures. It is commonly used in office and light industry settings where repetitive or awkward movements may lead to injury over time. Developed for quick on-site evaluation in office and industrial settings. One of Rolla's strengths is its simplicity and speed. You don't need lamp instruments or complex software. It can be applied on-site using just a paper form or basic software, which makes it ideal for time-sensitive ergonomics audits. Purpose: inform ergonomics intervention by identifying posture-based risk. The main goal of ROLA is to support decision-making by highlighting postures that are most likely to cause harm. It helps managers and designers focus on specific intervention, whether that is adjusting desk height, changing equipment layout, or integrating AI-based postures reminders. Anatomy of ROLA, targeting body regions and risk indicators. ROLA evaluates posture of the upper limb, neck, trunk, and legs. ROLA focuses primarily on the parts of a body most vulnerable to repetitive strain: the shoulders, elbows, wrist, neck, trunk, and legs. It analyzes these regions in pair to give a clearer picture of how body is positioned during a task. Each body segment is scored based on posture, force, and movement. The scoring is detailed. For example, a bent wrist or twisted neck gets a higher score due to its deviation from a natural low-risk position. Additional points are added if the posture is held for a long time or involves forceful efforts. Posture scores are grouped into two main sections, Group A and Group B. Rolla simplifies the evaluation by grouping body parts. Group A covers the arm mechanics and Group B looks at the core and lower body. Each group is scored separately, then combined into a final score that indicates the risk level and need for action. Understanding ROLA scoring system and interpretation. The, to indicate posture risk level. ROLA uses 1 to 7 scoring scale to indicate posture risk level The first roller score range from 1 to 7, where 1 to 2 means posture is acceptable and 7 means immediate investigation and ergonomic interventions are required. This clear scoring helps prioritize risk area without ambiguity. Scores are calculated by combining postural angles, force, and muscle use. Every body segment's posture is evaluated and adjusted for static use or applied force. These raw scores are fed into a standardized table to derive the final roller scores. This ensures consistency across different evaluators. Roller results guide immediate, short-term or long-term interventions. Once the score is obtained, it directly informs what kind of ergonomic action is needed. Lower scores may suggest occasional monitoring, while higher ones require more systematic changes, like adjusting tools, workflows, and even using AI tool to correct postures in real time. Rolla versus other ergonomics tools. A comparative overview. Rolla focuses on upper body posture in static or short cycle tasks. Rolla is best suited for tasks like in typing, assembly line work, or microscope use, where posture is fairly consistent and strain on the neck, trunk, or arms is more common than on other limbs. Other tools like Riba or OS assess whole body and dynamics tasks, while Rolla is posture specific. Tools like Riba rapid entire body assessment access whole body movement and the ideal for job involving lifting or shifting positions. OWAS is used for environment like construction or agricultural where large body movements are involved. Choosing the right tool depends on task type, environment, and risk factors. The key is to match the assessment tools with the nature of the work. Rolla is excellent for preliminary check or digital integration in office environment, especially when paired with AI for continuous monitoring. For more complex physical work, broader tools may be more suitable. Conducting a manual Rolla assessment. Step-by-step guide. Step 1. Observe the task and capture working postures. Start by watching the worker perform the task normally and either take a photo or note the postures during peak strains. It is important to avoid artificial poses. Capture what actually happened during regular work. Step 2. Score each body part based on joint angles and position. Use Roller's reference chart to assign a score to each body part based on how far it deviates from a natural position. For example, a raised arms or bent wrist gets a higher score due to increased ergonomic stress. Adjust a score based on force, repetition, and muscle use. After scoring posture, adjust for muscle use. If posture is held for long periods, and add points for any force or repetition. Once both group A and B are scored, use Rolla table to find the overall risk score and determine if action is needed. Common posture risks identified by Rolla in office setting. Forward head and neck posture during screen use. One of the most frequent observed risks is forward head postures. When users lean toward screens that are not at high eye level, it creates tension in the neck and shoulders, increasing Rolla Group B scores and long-term MSD risk. Unspotted are evaluated arms while typing or using a mouse. If the forearms are not supported by arm rests or the desk, users often evaluate their shoulders unconsciously. Over time, this contributes to muscle fatigue and poor circulation, which is reflected in high roller scores for the upper limbs. Twisted trunk or leaning due to poor desk layout. Trunk twisting occurs when frequently used items are not within easy reach. Leaning or rotating the body repeatedly can strain the spine and increase the risk of lower back problems. Rolla identifies such postures risk early to support workstation redesign. Heads-on demo, scoring postures from real workstation photos. Participant will evaluate sample workstation photos using the Rolla worksheet. So now apply that are learned by analyzing poster photos. Look closely at joint angles and body alignment. Then follow the Rolla scoring procedure step by step. This builds confidence in real-world ergonomics assessment. Use Rolla tables to assign postures, muscle use, and force scores. With the help of Rolla chart, assign score to each relevant body region. Don't forget to adjust for factors like holding up postures or exerting efforts. Combining A or B data to generate the overall risk score. Discuss result as a group and suggest ergonomics improvements. Once everyone has a final score, we will compare and discuss. We will identify what could be improved, such as adjusting screen height, adding arm rests, or using postures monitoring AI tools, and how these changes might reduce the ergonomic risk. Group activity, apply Rolla on your workspace. Obviously, live, agar if you get a photo from your office, you can use photo based. Participants will observe and assess their current posture or submit a workspace photos. Now you will take photo of your workstation postures or assess your current seated position live. Try to reflect a typical working postures rather than adjusting for the activity. This makes your assessments more accurate and meaningful. Individually complete the Rolla worksheet using two days reference material which is given end of the presentation. Follow the Rolla's worksheet just like we practiced. Pay close attention to the alignment of your neck, arms and back. Consider you maintain this position for a long period or if force or repetition are part of your routine. Compare results with peers and brainstorm one ergonomics improvement. After scoring, share your finding in small groups. Discuss what changes could be made, like altering desk height, using an AI-based postures alert tools, or improving chair support, and how these changes might reduce risk and improve comforts. Posture detection, AI and Rolla scoring tools. AI vision systems can detect joint angles and assess posture automatically. AI-powered tools use computer vision to track head, neck, arms, and trunk angles in real time. These systems remove subjectivity and allow continuous monitoring by mapping body data directly to Rolla postures categories. Wearable and IoT sensor enhance real-time posture monitoring. Wearable devices like posture belts or rest tracker can collect motion, and muscle strain data. When linked with AI systems, these tools can generate dynamic roller scores as the worker moves through the day, altering them when risky postures occur. Automated roller tools support proactive ergonomics interventions. The goal is to move from reactive fixes to proactive design. AI integrated roller platforms can alert safety teams about high-risk patterns before injuries occur, enabling data-driven redesigns, personalized coaching, or even smart desk adjustment. Using wearables and vision-based AI real-time roller monitoring. Wearable track postures deviation, angles, and static load duration. Devices like posture sensors or smartwatches collect joint movement and alignment data. This enables the system to assess how long a person holds risky postures, helping calculate more accurate and responsive roller scores. Vision-based AI uses camera feeds to monitor workstation behavior. Computer vision tools such as those using OpenPose or AI-driven webcams can analyze postures from standard video feeds. These tools recognize human body landmark and instantly generate posture score without physical contact. Integrated alerts prompt user to adjust postures before risk escalate. Once the system detect a risky position, like slouching or leaning too far forward, it can alert the user via haptic feedback, on-screen messaging, or ambient cues. This encourages micro-adjustment before strain become chronic. Integrating roller data into smart workstation design. Roller data highlights ergonomics hotspots work in workstation setups. When you analyze roller scores across multiple users or tasks, patterns emerge like constant neck strain due to low monitor or unspotted arms from improper keyboard placement. These insights guide practical workstation changes. AI system can dynamically adjust workstation elements. By connecting posture monitoring AI to adjustable furniture, smart system can offer real-time recommendations or auto-adjust setting. For example, desks can raise slightly if a user is slouching or the monitor can tilt to improve neck postures. Designers use Rolla Insight to create inclusive, adaptive workspaces. Rolla allows workplaces designers to make evidence-based decisions by integrating postures data early in the design process. Workspaces can be tailored for varying body types, physical needs, and user behavior, prompting long-term well-being. Designing UC intervention based on ROLA finding. Start with user feedback and absorb ROLA scoring. Effective intervention begin by pairing that user feel pain or fatigue with what the ROLA scores shows, high risk postures. This dual approach ensures changes are not just data driven but also personally relevant. Co-design solution with the employees, not just for them. A user-centered approach means collaborating with employees to co-create solutions. Instead of imposing a chair or tool, involve them in choosing which fits best, boosting commitment and long-term behavior changes. Test and refine intervention through iterative feedback cycles. After implementing changes like adjusting chair heights or screen positions, reassess using Rolla and ask for user Input: if scores improve but discomfort persists, further tweaking may be needed. Continuous feedback ensures the solution truly fits. Defining ergonomics KPIs using ROLA insights. Translate ROLA scores into measurable performance indicators. You can turn ROLA assessment into tangible metrics. For example, how many workstation setup score above a 4 in ROLA. Over time, this helps organizations monitor postures, risk, and improvement as part of safety KPIs. Set target for reducing high-risk postures across departments. After assessing current postures risk, set reduction goals, such as decreasing ROLA 6 to 7 score by 30% within a quarter. These department-level goals align health outcome and operational performance. Monitor trends using dashboard and real-time reporting tools. Digital tools can aggregate raw data and display it in dashboard, enabling safety manager to see trends, spot problem zones, and track improvements efforts across teams or locations, making ergonomics performance transparent and actionable. Case study example: how leading companies use ROLA and AI for ergonomic success. Tech firm integrated AI cameras to monitor desk posture 24/7. A global software company used computer visions to track employees' postures and workstation. Based on real-time ROLA scoring, workers received message to adjust it. This led to a significant drop in ROLA 6 to 7 scores and improved comfort across department. Manufacturing plant use ROLA to redesign assembly tasks. In a factory setting, ergonomics engineer applied ROLA to evaluate repetitive tasks. They found that certain tools force awkward trunk and rest positions. By redesigning work surface and tool layout, they saw a measurable reduction in injuries. Banking office added AI-assisted ergonomics dashboard for HR. A regional bank introduced posture monitoring dashboard for HR teams. Employees with persist high risk score were offered workstation upgrades and training. This proactive approach improved satisfaction and reduced sick leave due to neck and back issues. Let's have a group discussion. Future of ROLA in AI-driven workspaces. How can ROLA evolve with new AI and wearable technologies? So let's discuss such as virtual reality for posture simulation or real-time biometric wearables might make ROLA more dynamics and context-aware, moving from snapshot to continuous ergonomics coaching. What are the risks of over-reliance or automated ROLA system? Let's discuss, for example, monitoring fuel invasive. What boundaries should organize set to balance posture support with privacy and psychological comforts? And what are the ethical concerns? How can organizations scale ROLA-based ergonomics fairly across roles? So let's discuss how do we ensure ROLA-supported intervention reach employees beyond office desks. Discuss adjustment for your remote work, different your body types, or non-desk environment where traditional tools may not apply. Designing ergonomics policies backed by ROLA and AI data. Use ROLA Insight to set organization-wide ergonomic standards. When ROLA data is consistently collected, organization can define benchmark like limiting ROLA score above 5 and specify furniture or softwares that align with the ergonomic safety targets. These become actionable workplace policies. Align ergonomics policy with occupational health and compliance goal. Well-defined ergonomics policies reduce risk of legal exposures and show commitment to employee wellness. Linking ROLA-informed policies to HR and HSE framework strengthens compliance with labor safety regulations and ISO standards. Train staff on interpreting ergonomics data and taking corrective action. The effectiveness of policy relies on awareness. Training employees on ROLA basics empower them to act early, like adjusting chairs or reporting poor setup, and helps manager interpret dashboard and plan intervention correctly. Wearable technology and smart decks, tools that move with you. Ergonomics wearable devices like smart belts, posture sensors, and motion tracking wristband monitor how user move throughout the day. This variable provides feedback on poor postures, prolonged inactivity, or high exertion. Data collected helps personalize ergonomics adjustment and identify recurring issues. Smart desk and furniture. Height adjustable desks, intelligent chairs, and footrests are increasingly integrated with sensors. These smart furnishing detect user positioning and prompt movement or posture changes. They support an adaptive workspace that align to the user's ergonomics need in real time. Integrating data with systems. Data from wearable and smart furniture can synchronize with larger AI ecosystem. This integration enables holistic analysis and feedback across multiple tools and interfaces. It promotes unified ergonomic insight at the individual and organizational level. Wearable and smart desk makes ergonomics active and responsive. They collect real-time data and deliver user-centered prompt, making comfort and safety part of everyday work routines. Real-time feedback system coaching worker while they work. Instant correction prompt. Real-time system send notification or audio cues when user deviate from healthy posture. This gentle reminder helps correct habits without interpreting workflow. Timely alerts ensure that poor posture does not become chronic behavior. Custom feedback loops system adapt based on a user history and risk level. Someone prone to back strain may receive more frequent lumbar related cues. This tailored feedback makes ergonomic training more relevant and easier to sustain over time. Engagement through visualization. Dashboard showing postures, trend, session scores, or ergonomics grades. Engage user in self-monitoring. Visual feedback increases awareness and motivates behavior change more effectively than static rules or training videos. Real-time feedback brings ergonomic into our daily awareness. These systems offer just-in-time coaching that helps reinforce better postures and build long-term ergonomics habits. Data collection for AI in ergonomics. Building smarter system with better data. Source of ergonomic data. Data comes from wearable motion sensor, vision systems, productivity apps, and environmental monitors. Each source captures unique ergonomics indicators like joint strain, fatigue signals, or workspace usage pattern. The diversity of data enhances the accuracy of ergonomics AI. Data quality and volume. High quality data collected consistently over time allows AI system to detect subtle trends and anomalies. Volume is also critical. More data points help algorithm train better and avoid bias. Clean labor data ensures trustworthy insights and decisions. Ethical use and privacy. Collecting personal data requires strict protocol to maintain user trust. System must anonymize, secure, and limit data access appropriately. Balancing analytic with privacy is key to ensure user participation and ethical AI deployment. Reliable AI start with reliable data. Ergonomic systems depend on diverse, high-quality input, but they must also ensure transparency and privacy to be trusted by user and adopted at scale. Design thinking in smart workplace. Creative solution rooted in human experience. Empathize and define. Design thinking begins with understanding the user's pain point and needs through observation and interviews. Insights from this phase are used to clearly define the problem. This helps team avoid assumption and solve the right ergonomics challenges from the start. Ideate and prototype. In this phase, designer brainstorm multiple ideas and build low fidelity prototypes for testing. These might include desk configuration, workflow adjustment, or smart device layout. Rapid iteration ensures the only viable user-tested ideas move forward. Test and implement. Prototypes are evaluated with real user in actual context to validate comfort, usability, and safety. Feedback from testing is looped back into refinement. Once validated, solution can be scaled with confidence across team or departments. Design thinking ensures that smart workplace solutions are grounded in user needs and tested in real context. It promotes creative yet practical outcome by valuing feedback and iteration. Space planning with ergonomics intelligence. Designing workspace that think ahead. AI assistant layout optimization. AI tools can analyze floor plans, employee movement pattern, and equipment usage to optimize space layout. They help place frequently used items within easy reach, identify crowded zones, and minimize unnecessary motion. This improves both safety and workflow efficiency. Balancing collaboration and focus. Smart space planning considers the need for both teamwork and concentration. AI can access noise level, lighting, and foot traffic to recommend zones for collaboration versus quiet work. Ergonomics intelligence ensures arrangement support physical and cognitive needs simultaneously. Future-ready scalable design with flexible furniture and AI-informed modular layout, workspace can quickly adapt to new roles, technologies, or employee preferences. Ergonomics intelligence ensure that these changes remain aligned with comfort, safety, and productivity standards over time. Smart place planning blends AI with human factors to design efficient, comfortable environment. It supports dynamic work models while protecting workers' health and well-being. AI plus UCD, a holistic framework, combining intelligence and empathy in design. AI for real-time insight. AI processes vast ergonomics data to identify hidden risks and user behavior at scale. It provides timely feedback and personalized recommendations that continuously refine the work environment. It helps bridge the gap between data collection and design decision making. UCD for empathetic adoption. User-centered design ensures solutions address not just what AI detects, but what users feel and express. By involving people directly, UCD brings context and emotional insight that machines cannot fully capture. Together, they create more responsive and human systems. Synergy for better outcomes. When AI is predictive power is combined with UCD's empathy driven approach, workplace becomes smarter and more human friendly. This synergy leads to solutions that are not only efficient but also embraced and sustained by user. The combination of AI and UCD creates a complete framework that's both analytical and empathetic. It helps team build smarter, adaptive workplaces, and genuinely reflect user needs and behavior. Office versus industrial workplace design. Tailoring ergonomic solution to context. Office ergonomics focus. Office environment emphasize seated postures, screen ergonomics, lighting, and digital interface design. AI tools often monitor sitting time, typing angles, and eye strain. Smart furniture and adaptive lighting system enhance focus and reduce fatigue. Industrial ergonomics focus. Industrial setting deal with repetitive tasks, lifting, standing, and high motion activities. Solution must address force, reach zone, safety hazards, and vibration. AI systems here rely on wearable data and motion analysis to detect risk and suggest workflow adjustment. Context-specific design strategies. Each environment requires different tools and ergonomics prioritize. While office may focus on cognitive load and micro movements, factories demand physical risk mitigation. AI and UCD methods must be tailored to these distinct contexts to be effective. There is no one size fits all in ergonomics. Office and industrial settings demand different design approaches, technologies, and evaluation methods based on user activity and environment. Personalized workstation design, ergonomics that adapt to the individual. Why personalization matter? Each worker has unique physical strength and work habits. A fixed setup may be perfect for one person but cause strain for another. Personalized ergonomics design adjusts to individual needs to maximize comfort and reduce long-term risk. Adaptive workstation using AI input for posture sensors and behavioral data, smart desks and chairs adjust automatically. These systems remember preferred heights, angles, and schedule for sit-stand routine, creating a more responsive and health-supportive environment. User empowerment through customization. Empowering users to adjust their space, build ownership and engagement. Dashboards allow workers to track their comfort data, receive recommendations, and fine-tune their environment. This balance of automation and control drives sustained ergonomics behavior. Personalized workstations go beyond convenience. They are key to long-term comfort and performance. AI and user feedback together ensure that every space works for the individual using it. Predictive ergonomics risk modeling, anticipating risk before they become injuries. Data-driven risk prediction. Predictive models use machine learning to identify users who are trending toward injury based on pattern in their behavior and movement. By analyzing posture, fatigue, repetitive action, and environmental condition, these models can calculate a risk score that evolves over time. Early intervention strategies. With real-time risk prediction, organization can intervene before an issue becomes a medical problem. This could mean adjusting tasks, providing additional support, equipment, or even temporary reassessing high-risk users. Prevention becomes personalized and proactive. Continuous learning and adoption. As more data flows into the system, the model continues update to reflect new behaviors, job roles, and environmental conditions. This ensures ergonomic support remains relevant even as a task or team evolve, improving safety outcome long term. Predictive modeling enables a shift from reactive to proactive ergonomics. It identifies at-risk individuals early and help tailor intervention to prevent strain, downtime, and injuries. AI for adaptive layout and interfaces, dynamic workspaces that adjust automatically. Layout adjustment based on user data. AI can analyze how individuals interact with their space, like reach distance, time spent sitting, or traffic pattern, and make layout recommendations. These adjustments might include relocating frequently assessed tools or modifying desk configuration to reduce awkward movements. Responsive interface and displays. AI also enhances digital ergonomic system can change screen brightness, font size, or information layout depending on lighting postures, a time of day. This reduces high strain and improve cognitive performance during long work session. Environmental adoption. Smart system adjust airflow, lighting or temperature in responsive to user preferences and biometric feedback. These adaptive environments help maintain focus, comfort, and physical ease, all while improving energy efficiency and well-being. Adaptive system makes space responsive and innovative. By adjusting layout and interface element the real-time needs, they remove friction and enhance both comfort and efficiency. Data privacy in workplace monitoring, balancing insight with employee trust. Privacy concern with ergonomic monitoring, sensor and AI system collect sensitive data like posture movement and even fatigue levels. Without proper handling, this could lead to concern about surveillance, misuse or lack of transparency. Respecting user boundaries is critical for trust and adoption. Transparent data policies. Employee must clearly communicate what data is collected, why it is collected, and who has access. Transparent policies build trust and help users understand the benefits of ergonomics monitoring rather than fearing hidden surveillance. Anonymization and consent. Best practice include anonymizing individual data and allowing employee to opt in or out of certain features. When workers are part of decision-making process, it builds a culture of respect and ensure ethical AI implementation. Trust is cornerstone of ergonomics AI success. Ethical monitoring involves full transparency, consent, and strong data protection, not just technical excellence. Bias and fairness in AI ergonomics tools, designing for everybody equally. Identifying embedded biases. If AI is trained on data that is present only a narrow group such as average size male user, it may fail to support users of different sizes, gender, or physical abilities. This can lead to exclusion, discomfort, or even increased risk of certain groups. Inclusive data collection. To build fair system, it is essential to gather training data from the diverse population with varying physical profiles and job functions. This ensures that AI understands a broader range of human needs and avoids reinforcing workplace inequalities. Evaluating system fairness. Ergonomics tool must be regularly audited for bias. This includes checking if alerts or adjustments favor some users over others and whether all worker benefits equally from feedback or design recommendations. Fairness must be a continuous process, not a one-time check. Bias in AI is not just a technical flaw. It is a human problem with real consequence. Fair ergonomics tools must reflect the diversity of real user in both design and data. Balancing automation and human agency, supporting workers, not replacing them. Understand human AI roles. While AI can guide ergonomics improvements, humans still control their experience. This goal is to dictate behavior but to enhance awareness, support decision making, and reduce injury risk, all without removing user autonomy. Customizable automation. System should allow user to adjust setting, snooze alert, or fine-tune recommendation. This keeps users engaged and prevent fatigue or resistance to constant automation. Flexibility helps workers feel empowered rather than monitored. Encourage ownership of ergonomics. When AI supports rather than override human choice, users become more likely to engage with the system and sustain healthy habits. A well-balanced system reinforces good behavior while respecting personal control. Effective ergonomic AI respects the human element. When worker feels in control, they are more likely to use and trust the system, making long-term success more achievable. Live demo, ergonomic assessment using AI tool. Real-time ergonomic insight in action. Demo overview. The live demonstration showed how an AI ergonomics tool capture, analyze real-time postures and improvement. Using a webcam or wearable input, the system evaluates sitting postures, shoulder alignment, and head tilt while the user performs typical desk tasks. Visual feedback and alert. The interface provides posture scoring, real-time visual corrections, and feedback alerts. When risky postures are detected, it may display a skeletal overlay or traffic light indicator to show safe, natural, and dangerous positions as the user moves naturally. Practical application scenario. This demo brings theory into practice. Participants will observe how such tools can be used in on boarding, training, or everyday monitoring. This shows the potential of integration ergonomics AI into daily workflow to reduce discomfort and prevent strain-related injuries. The, this demo brings theory into practice. We will see how AI can monitor user, give feedback, and improve ergonomic without invasive process or extensive user input. Python example, poster data analytics behind the scene of ergonomics AI. Data input and structure. This example illustrates how poster data can be collected from sensor or video feed or structure into usable input. Group activity. Design a smart workspace. Apply AI and UCD practice. Challenge setup. Team will receive a functional user profile with ergonomic needs, job type, and workspace limitation. This task is to collaborative design a smart workstation that uses AI, sensor, and adaptive tools while incorporating UCD principles. Design consideration. Group should consider posture monitoring, feedback system, environmental control, and personalization. They must also think through user pain points, privacy, and usability. Sketches, mock-up, or digital layouts are encouraged. Presentation and discussion. Each team will present their design and explain how AICD, UCD informed their choices. This peer learning approach reinforces key concepts and encourages creative problem solving in realistic scenarios. This activity lets you synthesize what they have learned. It challenges them to design something functional, ethical, and user-friendly. Apply both data and empathy. Steps to deploy ergonomics AI system. Turning plans into action. Assessment and goal setting. The first step is understanding current ergonomics challenges and defining what success look like. This could involve employee surveys, injury data review, or observing workflow inefficiencies that AI could address. Selecting and testing tools. Organizations must choose tools suited to their environments. Wearables, computer vision systems, or adaptive furniture. A pilot phase with small teams helps validate the tools, iron out usability issues, and gather early feedback. Scaling and integration. Once validated, system can be scaled across departments and integrated with existing platforms like HR, safety or facilities software. Ongoing monitoring and optimization ensure the solution evolve as workplace needs changes. Deployment isn't just technical, it is organizational. It involves clear goals, user testing, and alignment with company workflows to ensure long-term success and adoption. Change management and employee training prepared people for smarter workspace. Communicating the vision. Employees must understand the value of ergonomics AI not as surveillance but as support. Communicating benefits like reduced discomfort and personalized comfort helps overcome resistance and build excitement. Training for confidence. Workers need hand-on training to use smart desk, posture apps, or wearable sensors confidently. Interactive sessions and digital guides ensure users feel empowered, not confused or overwhelmed by new technology. Building a feedback culture. Continuous feedback loops ensure the system work well in practice. Encouraging users to report issues and suggest improvement leads to better usability and stronger trust in the tool. Adoption depends on culture. Training and transparency helps workers feel part of the change, not subject to it. A sportive rollout builds confidence and long-term engagement. KPIs for ergonomics smart design. Measuring what matters. Health and safety metrics. Common KPIs include reductions in MCD injuries, reported discomfort, and absenteeism. These indicators reveal whether ergonomics changes are truly improving health outcome over time. Productivity and efficiency. Ergonomically smart workplaces often lead to smoother workflows and few task interruption. KPIs such as task completion time, user satisfaction, and poster adherence rates can quantify this improvement. Engagement and adoption. Metrics around user interaction with AI systems, like feedback, response rates, or customization use, show how well solutions are being embraced. High engagement typically correlates with better ergonomics outcomes. Metrics being accountability to ergonomics design, tracking health, efficiency, and adoption helps refine system and proves their real-world impact. Case study: Amazon warehouse ergonomics and AI, scaling safety with data. Background and needs. Amazon warehouse are high volume, fast paced environments with repetitive tasks. To reduce injuries, the company implemented AI-based monitoring system to track body movement and flag unsafe lifting techniques in real time. Technology in use. Wearable and computer vision detect improper posture and fatigue. Data is fed into predictive models that suggest ergonomics adjustment, while real-time alters coach workers toward safer movement. Results and reflection. Initial reports showed a drop in injury claims and improved task performance. However, the initiatives also raised concern about privacy and work autonomy, highlighting the need of ethical AI deployment in demanding work settings. This case highlights both the power and pitfalls of AI ergonomics. Results were strong, but balancing innovation with human concerns remain critical. Case study as a theme: redesigning physical demanding workstation using AI and ergonomic design, duration 30 to 40 minutes, and make a group of 3 to 5 participants. Learning focus: we will focus on how AI and ergonomic design work together to lower injury risk in fast-paced warehouse setting. You will practice designing from the worker's perspective, balancing innovation with trust, privacy, and practical usability. learning objectives. Identify the key ergonomics risks. We will learn to spot the key physical risks that contribute to long-term injuries in warehouse jobs, forming a foundation for ergonomics assessment. Apply user-centered design principles. We will explore how to involve workers in designing solutions, ensuring the tools and changes truly fit their needs and constraints. Utilize AI-powered ergonomics tools. This objective introduces students to how AI tools can monitor movement and alert users to risk before injuries happen. Develop empathy through immersive problem solving. You will engage in role play to better understand the physical and emotional challenges faced by workers, fostering empathy in design thinking. Case scenario. Workplace context. Set the scene of your team. Obviously, you have a composed of 3 to 5 member teams. This is a typical high volume warehouse where rising physical strain issues. Think critically about where injuries are happening. Lifting, reaching, and pushing are key stressor. Company goal. You need to introduce the performance challenge, improve safety outcomes significantly, but operation must keep running smoothly. You will evaluate whether and how AI tools can support this goal. Your redesign challenge. Your team must design a realistic and human-centered solution. Go beyond just tech. Address privacy, trust, and how the design effectively daily workflow. This quote helps reframe the task. The best ergonomics intervention may eliminate the strain altogether. Keep the worker's perspective central throughout your design process. Step-by-step case study structure. So we have a scenario introduction, then task observation, risk identification, AI tool, redesign the station, present and discuss and reflect and debrief. So these are the description in for, and then you have to prompt when to discuss with each other. Virtual key play role kit, redesigning physical demanding workstation. So now for your facilitator who is the group in charge, assign one role per participant via private message or email before the session. Obviously, we are sitting here, so you can do as you like it. Use breakout rooms for team discussion, 3 to 5 people per group. Ask each participant to stay in character during team design task. After the design phase, reconvene and debrief based on role influence. So role plays, Tania, a warehouse associates worker, uh, and frontline experience. The second is message to need to send. You are a Tania, a warehouse associate. You lift boxes all day, often with pain. You are a skeptical of tech that watches you or slow you down. Stay focused on speed and minimal disruption. Point 10 hours per working days and lower pain back, put interrupted. Workflow speed is on your top, and these are the points which you can read yourself. The second is Bob, safety manager, manager viewpoint, accountability plus budget. And this is the message for him. And these are the point which he working on the point. Sam, AI vendor, technology provider viewpoint and product adoption. And this is a message for him. And this is a point he needs to discuss. Jordan, union representative, advocate viewpoints, worker rights, and this is the message, and these are the points. Then Linda, shift supervisor, operation viewpoint. She will give operation viewpoints, daily oversight and message for her, and these are the points. So now everyone has their own message and points. Uh, Dr. Elena, ergonomist, design viewpoint, long-term safety, and message for her, and these are the points for her. And role by play, Tania, warehouse associate, workflow speed takes priority. There is a character summary, workflow speeds take priority, monitoring tools feel intrusive, physical strain remain unspoken but constant. Any tech that slow movement or flags posture adds pressure, not relief. This goal is to remove lifting entirely, not just improve it. Role profile, we already discussed it. Physical execution builds daily efficiency, feels like survival, alert, and sensor create anxiety, not sport. Solution must feel invisible, not controlling. Trust break the movement, productivity drop due to tech. Bob, safety manager. Character summary. Pressure comes from both sides, upper management and the floor. Results must be fast and visible. Injuries are rising, but resources are tight. Work by in fragile monitoring must lead to measurable change, not pushback. So role profile, metric drives decision making. Implementation must be efficient and palatable. No tolerance for delays or worker resistance. Solution must balance trust, budget, and speed of deployment. SAM, AI vendor, character summary. Technology is advanced, but user friction remain high. Alert can fatigue user quickly, sensor data shows risk clearly, but real-world acceptance is mixed. The system should support, not supervise worker. Role profile, already we mentioned. Effectiveness depends on user perception. Constant feedback must feel useful, not punitive. Performance metrics matter, but human factors shape success. Tech must blend into workflow without disruption. Jordan Union representative, character summary. Surveillance feels like control, constant fairness, and purpose must be clear. Trust erodes when tech track without benefits. Worker deserves a voice in every stage of design. Role profile, power imbalance grow with hidden tracking. Metrics can be misused. Safety without agency feels hollow. Design must protect people, not just optimize them. Linda, shift supervisor, character summary. Production deadlines dominate the day. Unsafe shortcuts happen under pressure. Morale drops when tech interferes with routines. Trust grows only when tool helps, not hinder. Role profile, disruptive tech invites complaints. Positive adoption depends on ease and value. Success hinges on smooth transition and worker confidence. Monitoring without context creates friction. Dr. Alina, ergonomist, character summary. Postures correction is not prevention. Data alone does not solve fatigues. Participation improves design outcomes. Ergonomics focus on designing out the hazard, not flagging it after the facts. Role profiles. Effective design eliminates the need for alerts. Root cause lie in layout, height and load, not posture data alone. System must adapt to human, not expect humans to adapt to tech. So this is a participant worksheets. So you need write down and copy them. So you have a task observation. What top? task observation is there, and ergonomics risk checklist. In this way, you need to make checklist and redesign plan and resketch. This is an option one, and option two, AI tool integration. So you select AI tools you want to include and explain why. And then presentation preparation before sharing your design. Top three risks you need to address. AI tool integrating and one challenge you anticipate in implementation. And this one is your work activities, team feedback rubric. So you have to make criteria, ergonomical risk identification, redesign logic and justification, AI integration and relevance, user-centered design thinking, collaboration and role balance, presentation and clarity insights. So these are your exceed expectation, which you give 3 points if you think, and then meet expectation 2 points, and need improvements this one. And the last one option is a score, right? So you need to write down the total score, how much you want to give them, right? And you have to mention that you peer as a facilitator, right? And your team name is should be here. So total score out of 18, exceptional, deep understanding and design maturity, proficient, solid application with room to grow, and developing is less than 12, need more alignment to ergonomics, AI, and user-centered goals. So here you have to give the optimal optional comments, strength, and suggestions. And then uh, individual assessment. So previously we have the teamwork, now here is the individual. Risk insight, AI tools, UCD design, creativity in redesign, communication and role participation, and reflective thinking. These are the details, and you have a score 1 to 5, and whatever, but for, let's say you say 2 here, so 6 will be here. So here you will write down as an individual assessment rubric. And the total score out of 90, advanced means excellent insights, ethics and applied design, proficient, strong understanding with minor gaps, 50 to 60, developing, basic contribution, need deeper analysis, and less than 50, emerging, limited understanding on engagement. So your comments will be here, and what the participant did well, it will be marks, and what would be improved or developed further. Case study, so role play debriefing session. Purpose to consolidate learning surface ethical and design tension and reflect on user-centered decision made during the activity, and format will be suitable for both in-person and virtual sessions. Sets the stage 3 to 5 goal transition from acting to reflecting. This movement invites participants to disengage from their character roles and return to their own voice. Acknowledge the intensity or complexity of what just unfolded and normalize any emotional reactions. Framing the transaction as a shift from storytelling to reflection helps clearly that next phase is about unpacking meeting, not defending decisions. And facilitator will explain like you what explainator is there. You just explore multiple perspective on safety, surveillance and design. Now you will unpack what happened. Case study, Amazon Vega still going on. Group reflections will be here. So goal is let each participant reflect on their role experience. And facilitator will ask them to discuss the prompt below and share a brief report out. So these are the prompt. What was your role? What conflict or disagreement? What concepts easy to difficult? Why? Did anyone feel unheard or overvalued? What trade-off did you make in your final design? And then the purpose is clarify motivation, behavior, success, competing priorities, reveal decision-making dynamics, highlight empathy or lack of inclusion, and link of ethical design thinking. Create space for every voice. Use a visible timer or shared slide to manage flow. Encourage summaries, not just dominate speaker, to share during reports out. So case study now thematic debrief. Goal is connect experience to core concepts: ergonomics, AI, ethics, and UCD. Use the following question with the group discussion. User-centered design, how will were real user need reflected in your final design? And what assumption did you make about the worker? So this section highlight whether solution stayed grounded in authentic needs or default to convenience or efficiency. Encourage participants to notice when design drifted towards abstract ideas instead of human realities. Explore how unchecked assumption can erase key user voices. AI tool and trust. What role did technology play? Sportive or controlling? What concerns emerge around surveillance and over alerting? These prompts help teams examine AI not just as solution, but as a social presence. Emphasize that good tech design must respect boundaries. Ask a student to consider whether the tools they proposed enabled anatomy or increased pressure and ethics and empathy. What ethical tension did you face? How did empathy shape your decisions? Empathy and ethics are often invisible in technical conversions. This discussion pulls those into focus. Ethical dilemmas often appeared when speed conflicted with care or safety, competed with privacy. Highlight that discomfort in this movement in a sign of meaningful learning. Closing reflection. Goal, anchor, your facilitator, learning on a personal level. Promote prompts. What is the one thing you will consider more differently with designing of real user? And what is the risk of changing without empathy? This movement crystallize takeaway instead of summarize the activities. Let each student internalize a shift in mindset. These closing questions build design maturity, grounding choices not only in function but in life experience. Encourage silence if needed. Quiet reflection often leads to deeper insight. For self-study, there are two case studies. Number one, case study related to Office 365 Smart Workspace. And the second is healthcare ergonomics monitoring. In next two slides, I will give you brief introduction of both case studies. So, case study Office 365 Smart Workspace, creating intelligent office environment. Smart Office integration. Microsoft Office 365 integrates with workspace hardware to offer posture alerting, environmental control, and productivity. AI tracks how long users stayed seated, adjusts lighting, and even prompt micro breaks or sustain wellness. User feedback loops. Employees receive personalized suggestions and report through dashboards that show their ergonomics pattern. These feedback loop encourage habit change and reinforce good ergonomics behavior over time. Outcome and insights. Pilot deployment led to measurable increase in user comfort, reduced eye strain, complaint, and higher satisfaction. Importantly, users retain control of the system, helping to build trust and ongoing engagement. The Office 365 workspace shows how even desk jobs benefit from AI ergonomics, blending insight, automation, and personalization to improve well-being. Case study: healthcare ergonomic monitoring, protecting caregivers with smart support. Challenges in healthcare setting. Healthcare workers face high ergonomics risk due to patient handling, long shifts, and multitasking. Many develop back pain or repetitive strain injuries which compromise care quality and workforce stability. AI and wearables in action. Hospitals have started using AI-enhanced wearable sensors that monitor lifting techniques, postures, and movement. Real-time alerts help workers avoid injury while analytical inform better shift planning and workstation design. Impact and adoption. Facilities using these systems reported lower injury rates and improved morale. Nursing appreciated personalized feedback and training programs become more effective thanks to data-driven insights. AI ergonomics is a lifeline for care workers. It reduces injury while supporting those who care for others, combining compassion and technology. The future of AI in workplace design, evolving from smart to intelligent. Continuous adoption. Future AI system will go beyond monitoring to actively adapting workspace in real time. From automatic height adjustment to predictive lighting changes, the goal is seamless interaction between humans and their environments. Cross-disciplinary innovation. The next generation of workplace AI will integrate insights from psychology, occupational therapy, and behavioral economics. The cross-pollination will help address both physical and cognitive stressor more holistically. Human AI co-creation. Worker will not just use smart systems, they will help shape them. Feedback loops and modular tools will allow for deep personalization, making workplace some more inclusive, creative, and empowering. The future is not just more automation, it's a deeper integration. Smart system will work with us, learn with us, and evolve alongside user needs. Emerging trends from sensor to simulation. Ambient intelligent AML refers to environments embedded with AI that respond seamlessly to human presence. Light, temperature, and workstation setup adapt automatically to user identity, mood, or schedule without manual input. Digital twins in ergonomics. Digital twins are virtual replicas of physical workspaces. These models simulate user behavior and test ergonomics changes before implementation, helping designers predict outcome and refine ideas with zero disruption. Transformational potential. These technologies make ergonomics planning more precise, scalable, and user-centered. They also enable real-time optimization, predictive maintenance, and ultra-personalized workplace experience. We are entering an era where spaces think and respond. These advanced technologies turn the workplace into a living system that evolves with its users. Key takeaway, what we have learned. AI empower ergonomics. AI enhances our ability to design safer, adaptive workplaces. AI enhances our ability to design safer, more responsive, and adaptive workplaces. It helps detect risk, predict needs, and personalize support at scale. UCD anchors technology in humanity. User-centered designs ensure AI tools remain grounded in real human needs. It helps build ethical, inclusive, and effective solutions that people trust and use. Success depends on integration. The most powerful ergonomic system combine technology, human insight, clear implementation strategy, and a strong feedback culture. This leads to healthier, more productive work environments. This is not just about tools, it is about transformation. AI plus UCD offers a new way to care for people through the design of their daily environments. Question and answer sessions. Your turn to share. Now let's deepen our understanding through open dialogue. 1. What challenges have you seen in ergonomic design? How could AI improve your workspace? What concern do you have about implementation? Resources. Continuing exploring. Books and research. Tools and platforms. Communities and network. Learning does not stop here. These resources offer deep dive into both the science and design of ergonomical intelligent workspace. And these are the references. The last one, red color rolla, is where you can get the worksheet which we've discussed in the early slides. Thank you. Please submit your question related to case studies. And sometimes questions are more important than answers. Thank you.